So let me give an example. So let's go back to the example that we discussed. So we have a normal random sample with sigma square known, and we consider pivotal quantity x bar minus mu divided by sigma divided by square root of n, which is a standard normal. So we pick A and B such that then the eccentric length of Ci is E minus A sigma divided by square root of n subject to A and B, F, C, C, D, Z, 1 minus alpha. And then we have seen in the previous theorem, we have seen that the interval, the shortest interval is that the F(a) equal to Fb greater than 0, and between A and B there is a mode. And so here for normal is symmetric, so it is a symmetric. So for shortest interval is we choose alpha 1 equal to alpha divided by 2, then A is Z, the percentile, with 1 minus alpha over 2, which is equal to minus Z alpha divided by 2. B is Z alpha divided by 2. So your A and B so Z normal 0, 1. Your A is Z minus alpha by 2, B is Z by 2. We have a mode at 0. So the usual, the constant interval for one step of z-test is the symmetric, and that's based on circuit distribution of the z, and then we choose alpha 1, alpha 1 equal to alpha 2 equal to alpha divided by 2 because that's the shortest one. So that's why we use this two-sided constant interval by choosing the same percentile. I mean, the same in the absolute value sense, the same percentile value. And if we have a case that sigma square is unknown, and then we have that, T distribution. This is equal to Tn minus 1. Is equal to that this standardization x bar minus mu divided by s divided by square root of n has a T distribution with n minus 1 degrees of freedom. So we are like pick A and B such that this probability that T distribution with n minus 1 degrees of freedom between A and B is equal to 1 minus alpha. The expected length of CI is the B minus A times expectation of S divided by square root of n subject to the integration of the T distribution between A and B is equal to 1 minus alpha. Still, for shortest interval, we choose the 2 alpha value is going to be same, and then by the theorem, and then your for A, therefore the lower bound 1 is the minus T n minus 1 and alpha divided by 2. For the upper bound, the B is going to T n minus 1 alpha divided by 2. So your A is minus T n minus 1 divided by 2. B is T n minus 1 divided by 2. So we can have the T critical value, percentile value that A is equal to minus T n minus 1 alpha divided by 2, and B is the T n minus 1 degrees of freedom and then alpha divided by 2. In that case, we achieve the shortest length, and which is the optimized interval. So this is also the reason why we use this interval for one sample one sample case when we don't know the sigma square. And then this is also coincides the inverting the hypothesis testing. So inverting hypothesis testing, that comes to the interval, and this optimized comes to the interval is going to be same. So what we use in the practice is the optimized one. Okay, let me start here. So we finished all the materials from chapter 6 to chapter 10. So I hope that you have learned many things in this course, and I hope that you can apply what you have learned in this course in your applied statistics course or in your future career.